Hello and welcome to the Aakash Byju's JEE channel. We are back once again live with Rapid Fire Mondays, and my name is Atiola, your host for the evening. Okay, so before we begin, let me know if I'm audible properly and if you can see me clearly. Alright, just give me a thumbs up, give me a yes, so we can quickly start with RFM. Another very exciting session of RFM, and this time the topic is work, power and energy. Alright, so we have audience coming in. Mihir, hi. Aakash, hello, how is going? Swastika, very good evening. Pankaj, Astha, Somnath, so many people coming in. It's very good to see all you guys. Very regular folks. Very exciting to see you guys over here in every session. I just love that. I love interacting with you guys. Yeah, we have a lot of thumbs ups, so we are good to go. All right, so we are live with Rapid Fire Mondays. If you have followed us, it's a quiz competition, and now let me introduce you to our participants. Okay, can we have our participants on the screen? All right, so we have Shashwat, Shashank and Aditi. How are you guys? Very warm welcome to RFM. How's it going? All right, so I'll ask one by one to all of you guys to introduce yourself. Tell the audience your name, where you're from, and what are your hobbies. And one more very important thing, which I thought I should bring it up, that this time has been really stressful for us. We are not able to go out. We're not able to meet our friends. So what is that one thing which has been your most effective stress buster? Okay, so Shashwat, why don't you start? Why don't you introduce yourself to the audience?
My name is Shashwat. I belong to Bihar. I live in New Delhi. My school name is JEE School. My hobby is playing cricket.
All right, awesome. So Shashwat loves playing cricket. So how have you been coping up with the pandemic? Okay, what is that one stress buster? When you are stressed out, what is that one thing that you do to relieve your pressure, to enjoy a little bit?
I generally watch cricket in TV and many times in YouTube also.
All right, awesome. So Shashwat looks like to be a very big cricket fan. Okay, Shashank, over to you. Please introduce yourself to the audience.
And my name is Shashank Kumar and I live in New Delhi and my hobby is watching and playing cricket.
All right, so we have another cricket lover over here. And now to Aditi, please introduce yourself to the audience.
Good afternoon, everyone. I am Aditi. I'm from an army background and I like to think about things like different things. I work on my speaking skills when I'm free, or I read books, different kinds of books, and many other things.
All right, awesome,
I just
Aditi.
spend time with my family and with my relatives, usually, like in the free time. That is the thing that helps a lot in relieving.
Awesome, Aditi. So Aditi seems like the person who enjoys the indoors. She reads books, she works on her oratory skills, and she loves spending time with friends and family. That's awesome. So guys, here are the rules. Here are the instructions for you. Okay, the first instruction is that if all three students give correct answer, then for each correct answer, the first person will get 4 marks, the second person is going to get 3 marks, and the third person is going to get 2 marks. Okay, and there's a time limitation. For each question, the maximum allowed time is 2 minutes, and be very careful that there is negative mark also. So 1 mark will be deducted for each incorrect answer. So no need to rush, take your time and answer, and take your best shot at answering it right in the first time. All right, and my audience, take out your notebook and pen as well, because you are going to play with us as well. Okay, so I'm expecting answers from you guys also. I'm going to see that in the chat. So when you have solved a question, do let me know what is the correct answer and play along. Okay, so we're going to have a lot of fun in this session. Work, power, energy, a very important chapter in physics, in all of physics, one of my favorite chapter in all of physics. So it's going to be really interesting. Okay, so participants, are you ready? Just give me a thumbs up. Awesome. Audience, are you ready? All right, so let's start with our first question. Here we go. All right, a force of 5 Newton making an angle theta with the horizontal, acting on an object and displaces it by 0.4 meter along the horizontal direction. If the work done by the force is 1 joule, then the horizontal component of the force is. That is the question. The options are A 1.5 Newton, B 2.5 Newton, C 3.5 Newton, and D 4.5 Newton. So participants as well as the audience, just go for it. We are talking about the horizontal component of the force over here. All right, Shashank has given the answer. What about the audience? Okay, a lot of answers coming from the audience as well. That is very, very good. All right, so Aditi has come up with her answer as well. And Shashwat as well has come up with an answer very, very quickly. That was done pretty quickly from the audience as well as from the participants. So Shashank, Shashwat and Aditi, all of you guys have given option B as the right answer. Now let's check what is the correct answer. And yes, all of you are correct. And the audience is also absolutely right. Okay, so Shashank gets 4 points, Aditi gets 3 points, and Shashwat gets 2 points. So Shashank has jumped to the leaderboard right from the beginning. Okay, so let's see if Shashank can maintain this lead in the first question. Alright, so before the second question, let's quickly look at the solution for this question, if any of you guys have any confusion. Alright, please show the solution for this question. Okay, so we have the force at an angle theta. So the force in the direction of displacement is going to be F cos theta. So the work done is going to be F cos theta into the displacement, and that is given to us as 1 joule, which means F cos theta is going to be 2.5 Newton, and we need to calculate F cos theta, which is the horizontal component of the force. Alright, that's the solution. And are you guys ready for the next question? Okay, here we go. Your second question of the evening. A constant force F1 is equal to 2I minus 4j Newton displaces a particle from 1 minus 1 2 to minus 1 minus 1 3, and then another force of F2 is equal to 3I plus 4j Newton displaces it from minus 1 minus 1 3 to 5 5 5. Displacements being measured in meter, find the total work done. That is the question. The options are A 46 joule, B 38 joule, C 40 joule, and D 36 joule. Okay, so F1 displaces the particle from 1 minus 1 to 2, 1 minus 1 2 to minus 1 minus 1 3, and then F2 displaces the particle from minus 1 minus 1 3 to 5 5 5. We have to calculate the total work done on the particle, and those are your options. Go for it. Harsh is saying ye to oral tha for the first question. Yes, absolutely. Harsh, you're absolutely right. That was a question basically to warm you up, and we are going to have many more interesting questions. We started with an easy one, but obviously we're going to have many interesting questions. Okay, but yes, it's a great advantage if you can solve it orally. That saves a lot of time. All right, so Shashank has come up with his answer. Awesome, Shashank. So we have answers coming in from the audience as well. All right, there's some split in the audience. So some people are saying one option, some people are saying the other option. Let's see which one is correct. All right, so Shashwat has come up with his answer as well. A lot of answers coming from the audience. All right, let me read the question once more so that it's clear. So there is a force F1, 2I minus 4j, and it displaces a particle from 1 minus 1 2 to minus 1 minus 1 3, and then there's another force F2, 3I plus 4j Newton, which displaces it from -1, -1, 3 to 5, 5, 5. And we have to find what is the total work done on the particle. All right. The audience has come up with a lot of answers, but what I see is there is a split in the audience. Okay, we don't have a clear option from the audience. Aditi, is the question clear? All right. Yes, Aditi has also come up with her answer. All right, so let's check out the answer for this question. May we have the answer, please? All right, option B, 38 joule is the right answer. And again, Shashank, Shashwat, Aditi, all of you are right as well. So all of you are able to answer this question correctly. And from the audiences also, we got most of the people came up with the right answer. So that's very amazing. All right. So audience, what do you think would be, what can you suggest? How did you go about the solution for this question? I want to know from you, the audience, how did you go about getting to the correct solution? Because most of you have, and while we are very happy to get the right answer, but it's also important to know what is the right concept. Okay, so Swastika here is telling me that, all right, so Ishan is telling me that we have to take the dot product of displacement vector and force, W1 plus W2, and that is correct. You're absolutely right. So all of our three participants have given the correct answer, but the first one to give the answer was Shashank. Was Shashank, followed by Shashwat, and followed by Aditi. Okay. Alright, so what I see is most of you people in the audience have got the answer right, and from what I see in the chat, most of you have got the solution also right, as in the process, the method that you followed for this question also absolutely right. Okay, so let's quickly go over the solution. So we can get the displacement if we subtract the two position vectors. So that is how we're going to get D1, and then the same way we are going to get D2. We are going to do the final position minus the initial position, and the work done is simply by a constant force, the work done is F dot S. So we have calculated the work done by the force F1 and then calculated the work done by force F2, and we have added them together and we've got 38 joule as the right answer. Okay, so can we have the scoreboard, please? So Shashank, I can see, is at 8 points. He is maintaining his lead. Shashwat at 5 points, and Aditi has caught up. She's at 5 points also. All right, interesting turn we have seen in the second question. Now if you guys are ready, let's go for the third question. Okay, here we go. So a force acts on a 1 kg particle in such a way that the position of the particle as a function of time is given by x is equal to 3t minus 4t squared plus t cube, where x is in meters and t is in seconds. The work done during the first second is, we have to calculate the work done during the first second. So the options are A 2.5 joule, B 5 joule, C 50 joule, and D minus 2.5 joule. So let's see how our participants are doing, and let's see how the audience responds this time. Okay, so the position is given as a function of time. That is the critical piece of information here. The position as a function of time, and the work done has to be calculated in the first second. A keyword over there, the first second. All right, so Lakshmi has come up with his answer from the audience. Okay, very good. We'll check if that is the right answer or not. We're waiting for our participants. All right, Somnath has also come up with his answer. So great participation from audience. That is lovely to see. Abhishek has a different answer. Abhishek says it's going to be option B. We're going to check. And Pradeep says it's going to be option A. So we have the audience split in its vote. That's interesting. So looks like this question is not as straightforward as it seems, because the audience is already split, as I can see. Option A is 2.5 joule, option B 5 joule, option C 50 joule, and option D minus 2.5 joule. So you need to take care of the sign as well. Priyanshu says that it should be option B. Sai says it should be option D. Priyanshu. Right, we'll check what the right answer is going to be. Abhinand is saying good evening. A very good evening to you, Abhinand, as well. How are you? All right, audience, I need more answers from you. I need more participation. What do you think is going to be the right answer? Okay, Sonam has come up with B. Rocking Boy has also come up with B. Some people have come up with A. So there are all kinds of answer we're getting. So this one looks like it is a bit tricky. But if you're good with concepts, if your concepts are clear, it should not be a problem at all. Alright guys, can we have the answer? We are closing to the time limit. It's almost 2 minutes. You guys need to hurry up. But at the same time, you don't need to give a wrong answer. Okay, only if you're sure, you should give the answer. You guys can also pass if you think that you don't know the right answer. There's no need to give the wrong answer. You don't need to risk giving a wrong answer and taking negative mark. Okay, so if you guys want to pass, you can pass. Okay, Shashank has come up with his answer. But if other people want to pass, then that's fine as well. You can always bounce back in the next round. All right, audience, can we have more answers? It's always great to see the participation from audience. All right, Swastika is saying that none of the options match. Swastika, I'm afraid that's not right. There's certainly a correct answer in one of these options. Check your calculations quickly. You might get the right answer. Alright, Sonam has come up with answer B. Amit has come up with answer D. Alright, so Aditi has also come up with her answer. Okay, so position as a function of time is given. X is in meters, T is in seconds. The work done during the first second is. Okay, the work done during the first second. That is the key in this question. Think guys, think. From position, what can you get? And I think we are done with the time. I think the time for the attempt is over. So we are going to stop here for this particular question. Okay, so I only got answer from Shashank. And Shashank has said option D. So let's check the correct answer for this question. And Shashank is right again. Shashank has just given a hat trick. Okay, so the correct answer is option D, minus 2.5 joule, and Shashank is at 12 points now. Awesome, Shashank. Shashwat and Aditi, not a problem. It's good to pass if you don't know the correct option. Keep trying, but there's no need to give a wrong answer, okay, because there's negative marking as well. Okay, so what is the solution? The solution is very simple, guys. We have the displacement. From displacement, what can we calculate? We can calculate the velocity by differentiating it once, and then we know what is the work energy theorem, that the work done by all the forces is equal to the change in kinetic energy. Okay, so we can calculate the velocity at t is equal to 1 second, and we can also calculate the velocity at t is equal to 0 second, and then we can find the change in kinetic energy, and that is going to give us minus 2.5 joule. Okay, so that is a simple way of doing this question. You could have also used f dx integral because the force is variable, so you could have used f dx integral, but according to me this is the smartest, the simplest solution. Okay, so most people in the audience also got option D, so that is very encouraging. Okay, so that is done. Shashwat, Aditi, buck up. You can always catch up in this round. Okay, so if you guys are ready, let's go for the next question. So next question is on your screen now. The kinetic energy of a body is increased by 21%. What is the percent increase in the magnitude of linear momentum of the body? Okay, that is the question. Option A, 100%, option B, 11%, option C, 10%, and option D, 21%. All right, that is the question. Those are the options. Go for it. Participants as well as audience, just go for it and try to get the correct answer. So the kinetic energy of the body has increased by 21%. So we need to find out what is the percent increase in the magnitude of their linear momentum. Option A, 100%, option B, 11%, option C, 10%, and option D, 21%. Alright, so Beena very quickly has come up with her answer. Anash has also come up with her answer. Guys, before giving the answer, just make sure that you have taken a good attempt, because sometimes when you try to solve questions very, very quickly, we can make a mistake. Okay, and that's not what we want to do. So take your time and try to answer the question in the minimum. You need to get it right in the first time. Alright, so Shashank has come up with his answer. Shashank is firing in all cylinders. Let's see if this is going to be right for Shashank, but we are waiting for answers from other participants. Okay, so we have answer from Shashwat as well. Lakshmi is saying B is correct. Some people are saying C is correct. Some people have come up with... Alright, so Aditi also has given the option. She has given her answer. So let's quickly check what is the correct answer for this question. Can we have the answer, please? Alright, so the answer is 10%, option C. So again, all of you guys are absolutely right. Okay, that's terrific. You guys have studied well, which I can certainly tell, because most of the questions you have, all of you guys have got it absolutely right. Alright, so we have Shashank at 16 points, Shashwat at 8 points, Aditi at 7 points. Shashwat and Aditi are catching up. Let's see if they can catch up soon enough. Okay, can we quickly have the solution for this question? Let's discuss the solution very, very quickly. Okay, so we know that kinetic energy, K2, the final kinetic energy would be 121 by 100 into K1. And then K2 by K1 becomes 121 by 100. And we know that kinetic energy is proportional to the speed square. So V2 square upon V1 square is going to be 121 upon 100. From there we find a relationship between V2 and V1. So we can multiply both sides by the mass. So we'll get the relationship between the final momentum and the initial momentum. So that we get as P2 is equal to 11 by 10 P1. So the percentage change is obviously going to be P2 minus P1 upon P1. Okay, and when we evaluate that, the answer is going to come out to be 10%. Okay, so most people in the audience were also absolutely right. Okay, so Shashank is in a comfortable lead at this point, but I'm sure Shashwat and Aditi have the potential to quickly catch up. Alright, so if you guys are ready, again, let's show the next question. Can we have the next question on the screen now? Okay, so pulleys and masses. In the shown pulley block system, strings are light, pulleys are massless and smooth, and system is released from rest. In 0.6 second, what is the work done by gravity on 20 kg and 10 kg block respectively? And you can take G is equal to 10 meter per second square. Okay, so you can see there are two blocks and there are two pulleys. One is a fixed pulley, one is a movable pulley, and it is released from rest. So in 0.6 seconds, we need to find out what is the work done by the gravity on the 20 kg and 10 kg block respectively. Okay, and for ease of calculation, we can take G is equal to 10 meter per second square. Alright, so let's see if audience is going to get the answer right this time. Okay, so most of the people in the audience are getting the right answer, and that is very, very encouraging. Alright, so Amit, Abhishek, Gopal, they have already come up with their answer. Let's see if our participants are going to get this right. Okay, we are talking about the work done by gravity on the 20 kg block and 10 kg block respectively. Okay, we're not talking about the net work done, we're talking about the work done by gravity on 20 kg block and 10 kg block respectively. Okay, so let's see if our participants are going to get it right this time. Okay, so answers coming up from the audience. Lakshmi has also come up with his answer. Sushmita, Roshan, Bhuvan and Sushmita. Hi guys, how are you? Good to see you guys on this session. Alright, so there's some confusion in the audience as well. We're not getting one particular answer. Okay, we're getting different answers from the audience as well. Okay, so the pulley block system has been released from rest. That is another key piece of information over here. Okay, and the ideal conditions are given. Pulleys are massless and smooth. Alright, our participants, I can see the tense look in their faces. They are really trying very hard. What about audience? Devansh is saying great revision tactic. Yes, Devansh, that's the idea behind RFM. It's a revision plus it's a lot of fun as well. So yeah, do keep attending these sessions, because in these sessions we do have a lot of fun. It's really exciting. Okay, so Shashwat has come up with his answer this time. Great going, Shashwat. I'm waiting for the other participants. Okay, answers coming from the audience as well. So okay, so Shashank has also come up with his answer. Come on, Aditi, you can do it. Just focus, and I'm sure. Yes, so Aditi has also come up with her. Not yet. All right. Audience, what do you think is going to be the right answer? Okay, I'm going to repeat the question. If somehow it is not clear, I'm going to repeat the question. So there's a pulley block system. Strings are light. Pulleys are massless and smooth. Shashank has come up with his answer. Going back to the question, the system is released from rest. In 0.6 second, what is the work done by gravity on 20 kg and 10 kg block respectively? You can take G as 10 meter per second square. All right. So answers coming from the audience as well. Great participation from the audience. But again, I see there's so many different kinds of answers coming. Okay, Harsh says C Pakka. Let's see, Harsh, if we're able to get that. All right, so we have So the time is oh, all right. So Aditi has passed. Okay, that's fine. That's absolutely fine. So let's look at the correct answer to this question. All right. So option C is the correct answer. C 240 joule and minus 60 joule. All right. So Shashwat has got it right. Shashank unfortunately could not get this right. So Shashank would be getting -1. Shashwat would be getting +4, and Aditi has passed the question, so she is not going to get any marks. Okay, so let's quickly look at the solution for this question. Looks like it was a tricky one. Okay, so let's look at the free body diagram. For the 10 kg block, 10g weight is going to act downwards, 2t tension is going to act upwards, and the acceleration is going to be upwards. For the 20 kg block, 2g weight is going to act downwards, tension T is going to act upwards, and if we have assumed the acceleration of 10 kg block as A, then the acceleration of the 20 kg block by constraint is going to be 2A. And then we write the equations. For the 10 kg block, we can write it as 2T minus 10G is equal to 10A. And for the 20 kg block, we can write it as 20G minus 10 is equal to 40A. Now, two variables, two equations, we can solve that, and we can get the acceleration of the 10 kg block as G by 3. And then we can find the displacement, because once we have found the acceleration, then the displacement is simply going to be half AT square, because initially the system was at rest. Okay, so once we have found the displacement, then the work done on the 20 kg block is going to be mg into the displacement, which is h, and it is going to be positive. Okay, because the weight is acting downwards and the displacement is also downwards. Okay, so the cos of theta becomes 1. So that is going to give us 240 joule, and the work done on the 10 kg block is going to be minus mgh by 2. So first of all, it is going to be negative because weight is acting downwards and the motion is upwards. And secondly, using constraints, we can say that the displacement of the 10 kg block is going to be half of that of the 20 kg block. Hence, there is an h by 2 over there. So from there, we're going to get minus 60 joule. Okay, so Shashwat has come very close to Shashank. That's a great comeback from Shashwat. And I'm expecting the same kind of comeback from Aditi. Shashank still is in the lead. Let's have a look at the leaderboard. Okay, so Shashwat is at 12, Shashank is at 15, Aditi is at 7. Shashwat has to a certain extent caught up, but let's see if Shashank is going to carry on with his lead. Okay guys, if you're ready, let's get to the next question. Very good competition going on over here. Next question please. So a block of mass 3 kg is kept on a 6 kg block, which is kept on a smooth surface. The coefficient of static friction between them is 0.3. A force F is applied on the upper 3 kg block, and it is on the verge of slipping when the system moves together for a distance of 1 meter. Calculate the work done by the static friction on 3 kg and 6 kg block respectively, and you can take G as 10 meter per second square. And the options are A 9 joule and minus 9 joule, option B 0 and 0, option C 9 joule and minus 18 joule, and option D minus 9 joule and 9 joule. Okay, so the participants are working this out. In the meanwhile, audience, what do you think is going to be the right answer? Quickly solve that and let me know. Okay, Shanpreet is saying, sir, please teach ordinary sessions as well. So Shanpreet, we have sessions every week. So apart from Rapid Fire Mondays, we have JEE Mission 2022 also going on. We are revising there. We take up topics, we revise, we discuss. It is a very, very interactive session. It's going every week. So you're welcome to join that session and we can have a chat there as well. All right, so answers have started to pour in from the audience. Okay, this time a lot of people are inclined towards one particular option. So let's see if the audience gets this right this time. All right, Shashank has to maintain his lead. Shashwat is very close. He might catch up in this question. Aditi also has a chance. We still have a lot of questions left. So Aditi also has a fair bit of chance to catch up with these guys. Let's see what's going to happen. The competition is getting intense. and so is the energy level of the audience. All right, so many answers coming in. That's wonderful. Great to see such participation. It's absolutely wonderful and it's very encouraging for all of us. All right, so we have a question where friction is involved. So we have two blocks. So one block has a mass of 3 kg, the other block has mass of 6 kg. There's friction between the blocks, but the floor is without any friction. And the force is applied on the upper 3 kg block, and the key hint here is, alright, so Shashank has come up with his answer. Shashank looks very determined to keep his lead going. Shashwat is working hard to catch up with Shashank. Aditi also looks to be working very intensely. Okay, and answers are coming from the audience. Alright, so Aditi has also come up with her answer. Now we are waiting for Shashwat. Alright, so Rishabh is saying solve करने की ज़रूरत ही नहीं है. Rishabh, I agree. The question is very long, but the solution is very short. I agree with you. It can be done, it can be worked out orally as well. But the trick here is to find the right answer and in the minimum amount of time. Alright, so a lot of answers coming from the audience as well. Some people are saying A, some people are saying D, some people are split with C. Let's see what the right answer. Alright, so Shashwat has also got the answer, and Shashwat, Shashank and Aditi, all three of you have opted for option D. Now let's look at what is the correct answer to this question. Can we have the answer please? And D is absolutely right. All three of you are correct yet again, and that is fantastic. So this time Shashank got it right first, followed by Aditi and followed by Shashwat. Alright, so before we go to the leaderboard, let's look at the correct solution for this question. And as I said, this question was pretty simple. It was pretty straightforward. So a lot of data was given to confuse you, but if you look at this question very closely, it's not difficult at all. In fact, as a lot of people in the audience said, it can be solved orally as well. So I want to know from the audience as well. So before we give the answers, so I would like to know from the audience that how would you solve this question? Okay, how would you solve this question orally or without much of calculation? I want to know from the audience, how would you guys go and approach this question? Alright, so Vidit is saying it must be negative, it must be equal to D. Direction wise, friction force निकालना है पहले. That is correct. तो पहले तो friction force ही निकालना पड़ेगा. Okay, so the trick here is that the friction which is acting between the blocks is static friction. Right? It is going to be static friction because there is no relative slipping, and the key word here was that it is on the verge of slipping, which means that the maximum value of static friction is going to act. So that is the free body diagram of the blocks. So the frictional force is going to be mu s into N1 because N1 is the normal force between the blocks. So that we can calculate is going to be 9 Newton, and from Newton's third law we know that the friction, the magnitude of friction is going to be same on both the blocks. But the difference here is that on the upper block the friction is going to be towards the right, and the displacement is also going to be towards the right. Okay, so I'm sorry, on the upper block, on the 3 kg block, the friction is going to act in the leftward direction, but the displacement is going to happen in the rightward direction. Okay, but on the lower block the only force which can move it is the frictional force, so the frictional force is going to act in the rightward direction. Okay, in both the cases the work done will have a magnitude of 9 joule, but for the first block it is going to be minus 9 joule because the displacement and the force are in opposite direction. So correct option is going to be option D. Well played all of you guys, very well played. So Shashank maintains his lead. Shashwat is also catching up with Shashank. Aditi is also fighting very hard to catch up with these guys. Okay, so Shashank is at 19 points, Shashwat at 14 points, and Aditi at 10 points. Right, that's the scenario over here, and this game is still open. It can go anywhere. Alright, so if you guys are ready, let's go for the next question. May we have the next question on the screen, please? A block of mass m is equal to 3 kg is pulled by a force F is equal to 50 Newton upwards through 2 meter height in vertical direction. It takes 8 seconds to lift the mass. Find the average power delivered by the force. Option A is 12.5 watt, option B is 25 watt, option C is 20 watt, and option D is 50 watt. Yes, Mr. Music, it was an easy answer, easy question, the last question. But let's see if the audience can answer this one, and how fast can the audience answer. Can they answer before our participants, or the participants are going to take the lead over here? Okay, so the answers have started to come. That's excellent. All right. So we have some people saying C, some people saying option A. So this looks like the audience is equally divided between C and A. Now I want to know from the audience your solution as well. Don't just give me the answer, but give me the solution as well. Let me see if we have got the concept absolutely right, because that is the most important thing. All right, our participants are working very hard to get this answer. Let's see who gets this one first. A lot of people are saying option A, and a lot of people are saying option C as well. Okay, so we have to calculate the average power delivered. So we have to think, what is average power? What is the definition for average power? How do we calculate average power? Alright, so Abhinav has come up with the right solution. You're absolutely right, Abhinav. Your approach is absolutely right. And here we have the first answer coming in from Aditi. Let's see if Aditi gets this right this time. And Shashank has given his answer as well, closely followed by Shashank. Shashwat has also given his answer, and yet again all of you three guys have given the same answer as option B. So let's check if this option is the correct option. Can we have the correct answer, please? Option A is absolutely correct. That is again very well played by all of you guys. Okay, so Aditi has caught up a little bit here. Aditi was the first to answer. She gets 4 points, followed by Shashank, who gets 3 points, and followed by Shashwat, who gets 2 points. So let's quickly look at the solution for this question. It was a very straightforward question. So the force is in the upward direction, and the displacement obviously is also going to be in the upward direction. So we can calculate the work done as F into H. And then what is the average power delivered? It is the total work done divided by total time. So the work done was 100 divided by time 8, and that gives us 12.5 watt. Okay, so all we had to know was what is the definition for power. If we know that, we could have solved this question very easily. And so did all of the participants, and so did the audience. So there's a great competition going on over here. The competition between the three participants is getting more and more intense. All right, so let's see if Shashank is still going to maintain his lead, because we have seen that Aditi has caught up a little bit with Shashwat and Shashank. All right, so if you're ready for the next question, let's go for it. Can we have the next question on the screen, please? A man is pulling a block resting on the ground by applying the force F is equal to 20T plus 40 Newton as shown in the figure. If the pulley is frictionless and mass of the block is 4 kg, find out the power delivered by the force at 3 seconds after the man starts pulling the block. Take G is equal to 10 meter per second square. Option A is 2250 joule per second. Option B is 5250 joule per second. Option C is 3000 joule per second, and option D is 1250 joule per second. That is the question, guys. Let's see who gets it right this time. So Kuldeep is asking, sir, is air is in this question, gravity is not in play. So the value of acceleration due to gravity is given, Kuldeep. So I think I've answered your question. And obviously we are taking ideal conditions, so you don't have to consider any air drag, etc. So I hope I've answered your question, Kuldeep. Alright, I see the intense faces of our participants. They are playing extremely well, I must tell you. Most of the answers, all three have got it right most of the times. So very strong competition going on. And the audience is also giving a very tough competition to the participants. A lot of good answers have come from the audience. Most of the time the audience has got that right. Alright, Kuldeep, if you're asking about the previous question, in the previous question, we had to calculate the power delivered by that particular force. So the gravity is not going to come into the picture because we'll just have to consider the work done by that particular force. Okay? The overall power delivered was not asked, the power delivered by the force was asked. That is why we had to just look at that particular force. Aki says, hi sir. Hi Aki. Alright, so we have the answer from Shashank. So Shashank has bounced back very strongly. Let's see if he gets this one right. So Shashank has come up with his answer. Amrit says, hi. Hi Amrit, how's it going? Good to see you here. Alright, so a lot of answers are coming in from the audience as well. Some people are saying C, some people are saying A. So again, there seems to be a split between the options that the audience is giving. Alright, but we are waiting for the participants. Shashank has already come up with his answer. We are waiting for the other two participants. Let's see if they are able to get this right this time. Right, some people are saying option B, some people are saying option C. Looks like the audience is divided on this one. Alright, so Kiran is saying, I'm your new student, sir. That's great, Kiran. And I hope you keep attending these sessions because these are informative as well as a lot of fun. Abhishek is asking, sir, F perpendicular to block motion is... not sure, Abhishek, what you mean there. If you can clarify that, I can probably answer your question. Alright guys, if you are not sure about the question, alright, so Aditi has come up with her answer. And so has Shashwat again. And for the nth time, we have got all the participants giving the same answer. Alright, so let's check if this is going to be the correct option or not. May we have the correct answer, please? Okay, so the answer has come out to be 2250 joule per second, and most of the people went for 5250 joule per second. So probably everyone had missed something in the question. Okay, in the audience there were some people who were saying option B, but there was a split in the audience as well. Alright, so all of you guys, very unfortunately, are going to get -1 this time, but we still have questions and you can still bounce back. Alright, so this looks like a tricky one, so let's look at the solution for this question. Okay, so the tension is going to be the force applied by the person, which is 20T plus 40 Newton, but there's going to be gravity acting as well. So the net force is going to be F minus mg, and that should be equal to mass times acceleration. So from there, what we do is we can find the value of acceleration, which is 5t. Now this you can use to write it as dv by dt. So we can write acceleration, which is 5t, is equal to dv by dt, and then we can take v on one side and we can take dt on other side, and then when we integrate it, we're going to get the value of v. Okay, and we get the value of v is 22.5 meter per second. And what is power delivered? The power delivered, the instantaneous power delivered is F dot V. So basically what we have done is we have calculated the value of the velocity at 3 seconds. So we have calculated F dot V. Now F and V are going to be in the same direction, so cos 0 is going to be 1. So it is simply going to become the force at 3 seconds multiplied by the velocity at 3 seconds, and that is going to give us 2250 joule per second. Okay, so option A is going to be our correct option, and unfortunately this time participants have got that wrong, so you guys are going to get -1 for this one. But no worries, we still have more questions and you can always bounce back. Okay, so this question was a tricky one where we forgot that there's gravitational force acting as well, and someone in the audience did mark it out, did point it out that there's gravitational force we have to consider or not. Okay, so if that is fine, let's go to the next question very quickly. Can we have next question on the screen, please? So we have a question on spring. If the energy stored in a spring A is 20 joule, then energy stored by spring B under the same stretching force is. The options are option A 10 joule, option B 25 joule, option C 40 joule, and option D 35 joule. Alright participants, go for it. Audience, go for it. Let's see who gets this right this time. Jamira is saying hi sir. Hi Jamira, how is it going? Good to see you here. Aki is saying, sir, I love Baiju's classes. That's very encouraging for us, Aki. The love that you're showering on us, that keeps us going. That keeps us motivated to get back, come back again with better and better sessions. Thank you so much for that. Okay, so audience have started to come up with the answers. Shashank is very determined to carry on with his lead. Aditi has also answered, given her option. We're waiting for Shashwat now. Shashank is very determined to keep his lead going. He does not want to let go of that. Okay, Aditi is fighting very hard to get back. Aditi is playing very well, and who knows, maybe she can catch up very soon. Okay, so our audience is also giving the answer, and most of the people in audience are giving the same answer, which means they have got this right as well. Alright, so Shashwat has also come up with his answer, and yet again all the participants have given option A as their answer. So can we have the correct option on the screen, please? Okay, so option C 40 joule is going to be the right answer. Okay, very few people in the audience were able to spot that as well. All right, so we are getting some tricky questions, and it is trapping our participants as well as the audience. Okay, so I think there's some confusion going on regarding the questions, so let's look at the solution first. Okay, the first thing we need to clarify here is, guys, that F is acting on both sides of the spring. Then what is the force acting on the spring? It is going to be F, not 2F. Okay, that is the first thing which has to be clarified. Maybe some people got that wrong. So the net force on the spring, they have taken it as 2F. Okay, so remember this very well, that it may happen that the left end of the spring is connected to a wall. It is fixed to a wall. Okay, in that case, when you are applying a force, then there is force F acting on both sides. Okay, in any case, there is the same force acting on both sides of the spring. Okay, so the energy stored in spring B is going to be half K xp square. Xp is the elongation, so that is going to be half K multiplied by what will be the value of xp. So the force is F, and F should be equal to K into xp. Okay, the force exerted by the spring force is going to be K into xp, and that should be equal to F. Is that right? In that situation, okay, in that situation, the spring is going to be in equilibrium. Is that right? So that is going to be half K into the value of xb is going to be F by K, and then the square of that. So we get F square upon 2K because of that. And then if we look at the spring A, so it is going to be half into 2K, because the spring constant is 2K multiplied by XA square. And what is going to be the value of XA? So K into XA is the spring force, and that should be equal to, 2K into XA is the spring force, and that should be equal to F. So XA will come out to be F by 2K and the square of that. Okay, so if we do that, if we solve that, we're going to get EB upon EA is equal to 2, which means EB is going to be 40 joule. Okay, so I guess there was some confusion. This was a slightly tricky question, and it trapped our participants and the audience as well. Okay, so we have -1 for all the participants this time, but no worries, we still have more questions, and we have chance for everyone to bounce back or to carry on with their lead. Okay, so audience, if you're ready, participants, if you're ready, let's look at the next question. Can we have the next question now? A small block of mass 10 gram is pressed against a horizontal spring fixed at one end to compress the spring through 5 centimeter. The spring constant is 100 Newton per meter. The spring is located on a frictionless horizontal plank located at a height of 5 meter from the ground. When the block is released, what horizontal distance will it travel after leaving the plank before it hits the ground? You can take G is as 10 meter per second square. Options are option A 1 meter, option B 2.5 meter, option C 5 meter, and option D 1.2 meter. All right, so we are beginning to, so answers are coming from the audience already. So Jamira has given her answer. Jamira, it's fine to write it once. We can see that. I see what option you have given. Let's see if that is right or not. So Taran is asking, sir, these guys are in which class? Our participants are in class 11th. Okay. Jamira has come up with her answer. Sankalp has come up with his answer. Let's see if the audience can outdo the participants this time. All right. So in the audience, most of people have come up with the same option. So let's see if that option is the right option or not. Okay, the concept is simple, guys. We have a spring. Again, the mass is attached to it. It is compressed, it is released, and then falls off the frictionless surface and then falls on the horizontal ground. So what I can understand is, obviously there is work energy theorem involved, but there is also a little bit of kinematics involved, if you can see that. Yeah. So Swastika, I'm not sure how many questions are left, but I don't think many. Alright, Pulkit has also come up with his answer. Rishabh has also come up with his answer. There's great participation from the audience. Just amazing to see that. Alright, so I see participants are taking a bit of time to solve this question, but that's fine. The key objective is to get the answer right. There's no point in giving the answer very quickly and getting that wrong. There's just no use. Alright, so Mysterious Man, Apurva, Rishabh, all of you have come up with your answers. Lasya is asking, sir, will these questions help for IIT and JEE Mains? Of course, Lasya, these questions are from Work Power Energy, which is part of our syllabus. So yes, definitely this is a good revision for the audience, for anyone who is watching this session. So it is going to help in your JEE exam as well. Okay, and that is the objective, to do revision but in a slightly fun manner. Okay, so Mysterious Man has also come up with his answer. Rishabh, KK, all of these guys have come up with their answer. So audience, right guys, we are running out of time. If you have to answer, you'll have to answer quickly. But if you don't know the correct answer, you can always pass. There is no point on taking the negative mark. So Shashank has come up with his answer. And so has Shashwat. So time is running out and time is of essence in this rapid fire Monday. Alright, so we have many different kinds of answers coming from the audience. Some people are saying A, some people are saying C, some people are saying D. So again, this looks like a little tricky question. Let's see if our participants have got this right this time. Last two times. Alright, so Aditi has also come up with her answer. So again, not a surprise. All of you guys have given the same answer. So let's see if this is the right answer or not. Can we have the answer, please? Okay, again, this is a hat trick of wrong answers. So C, 5 meter is the right answer. Okay, so all of you are going to lose 1 marks over here. Guys, pay attention. There's no point of answering if you're not sure about the question. Okay, this is just going to give you negative marks. Alright, so can we have the solution, please? Alright, so obviously we are going to apply conservation of mechanical energy. So let's say the compression of the spring was X. So the change in potential energy is half kx square, and that is going to be converted. So the loss in potential energy is going to be the gain in kinetic energy, and that is going to be half mv square. So all these quantities we know. So from there we can find out v as 5 meter per second. So the moment the block leaves the platform, its velocity is going to be 5 meter per second. Then what do we need to do? So this is simple kinematics in 2D. So first we are going to apply y is equal to uyt plus half ayt square in the vertical direction. Okay, we know what y is, so from there we can calculate what is time. So time is going to be 1 second, and then we can apply kinematics in the horizontal direction. So we can write x is equal to uxt plus half axt square. Acceleration in the horizontal direction is going to be 0, which means x is simply going to be ux into t. So that is going to give me 5 into 1 is equal to 5 meter. Okay, so that is the correct option. Option C. Again, you guys could not get that wrong, but don't worry, we'll still have a few questions, and the participants are very, very close. Okay, can we have the leaderboard once again, please? So Shashwat is at 13 points, Shashank is at 19 points, Aditi is at 11 points. So Shashwat is, Shashank is still in the lead, but Shashwat is not far behind, and Aditi is also not very far behind. And a couple of questions, it may happen that these guys catch up, but let's see if that is going to happen or not. Let's quickly have the next question on the screen, please. Consider the situation as shown. Initially, the spring is unstretched when the mass m is released from rest. Assuming no friction in the pulley, find the maximum extension in the spring. And the options are A, mg by k, B, mg by 2k, C, 2mg by k, or D, 4mg by k. Okay, participants, are you able to see the question clearly? If not, just let me know. Alright, so participants are going for it. Audience, what are you waiting for? Go for it and let me know what is going to be the right answer for this one. Okay, so we have a spring which is in the unstretched state in the beginning, and then this mass is released from rest. So we have to find out what is the maximum extension in the spring. Alright, so Radha has given her answer. Mihir has also given his answer. Dev has also given his answer. So answer coming in from the audience, and the audience look to be split this time. Alright, Shashank has come up with his answer. So if Shashank gets this right, his lead is going to be very, very difficult to beat. Okay, so this could be the deciding moment in this round. Alright, Aryan has also come up with his answer. Bhamini has also come up with her answer. Let's see if these are going to be right or not. Okay, Kunal has also given a good explanation for the question. Let's see if that is right. Okay, so Shashwat has come up with his answer. Let's see if Aditi is able to get this right this time. Audience, what about you guys? So I've got all kinds of answers from the audience, A, B, C and D. Alright, so Aditi has also got her option, and this time, this is the first time probably it has happened that all the three people have given different answers. So Shashwat has voted for option A, Shashank has said it can be option B, and Aditi is sure about option C. So can we have the correct option on the screen, please? It's option A, and Shashwat gets this right. So Shashank is going to get -1, Aditi is again going to get -1, and Shashwat has come very, very close to Shashank. Very well played, Shashwat. You are playing really, really well. Okay, so keep that going. Shashwat gets +4 points. So the situation is getting much more tense over here. So Shashwat is at 17 points, a shade behind Shashank, who is at 18 points, and Aditi is at 10 points. Aditi, don't worry. There are still a couple of questions. You can obviously catch up with these guys. Alright, so try harder. And with that said, let's go to the solution for this question, because there seems to be a little bit of problem. Okay, so at maximum extension, mass m is at rest, right? When is the maximum extension going to happen for the spring? When the mass comes to rest. Which means if we apply the work energy theorem, then the work done by the external force should be equal to the change in kinetic energy plus the change in potential energy. But the key here was constraints. That if the block goes down by a distance of x by 2, the spring is going to get elongated by x. Can you see that? Okay. So if you lift the mass m by a certain distance, then thread would be freed from both sides. So let's say you take the mass m up by x. So so x on left side and x on left side. So 2x thread is going to become free, but the left side has a rope, and that is inextensible, that is fixed. So who is going to take up that extended length? The spring is going to take up that extended length. So the extension of the spring is going to be twice of the displacement of the block. So that is why we have substituted half kx square, and that is going to be equal to mg x by 2. So the distance by which the block has come down is x by 2. So the loss in potential energy is going to be mg x by 2. That is going to be equal to the gain in kinetic, gain in spring potential energy, and hence x is going to go, hence x is going to be mg upon k. So option A is going to be the correct option. Very, very well played, Shashwat. You are very close to Shashank now, and let's say in the next couple of questions you're going to surpass Shashank or not. Okay, so audience, participants, this is getting very, very tensed. Okay, so if you're ready, let's go for the next question. Can we have the next question on the screen, please? In the figure as shown, block A is of mass m and block B is of mass 2m. The spring has force constant k. All the surfaces are smooth and the system is released from rest with the spring unstretched. Maximum extension in the spring is. Okay, so another question on maximum extension of the spring. What are options now? A, mg by 2k, B, 4mg by k, C, 2mg by k, and D, mg upon 4k. So guys, be careful and very carefully solve this question. We don't want to get that wrong, okay, because that really hurts. It gives us -1. We don't want that. So take your time and get the right answer up front. Alright, so as always, our intelligent audience, the answers have started to come in. Okay, so Roja has given her answer. Mihir again has given his answer. Inish. So Mihir has also given his answer. Ashwi is asking which class they are. Ashwi, they are all from class 11th. Probably most of you guys would also be from class 11th. Okay, so Arnav, Abhinav have given their answer as well. So audience is very quick to give answers, but let's see if audience have got this right or not. Okay, so many different kinds of questions coming from audience. Some are saying A, some are saying B, some are saying C. So again, there's a split in your verdict. So let's see who is going to take the lead this time. Is Shashwat going to take the lead now, or is Shashank going to continue with his lead, or is it Aditi who comes very close to these guys? Alright, so Radha is saying, I bet it is C. Radha, sure, we'll check if that is the correct answer. So Ashvi is saying, not able to solve a single question, sir. Ashvi, not a problem at all. So there are two things which can happen. One is that if you're in class 11th and you're not able to solve these questions, then probably you have not studied the chapter very well. There are some concepts which are missing. So you can always go back, revise, okay, and you can then try these questions again. Okay, so probably what the thing that is missing is probably you're lacking a few concepts. Okay, you've probably not studied this chapter very well. So you can always revise. So Ashvi says you're in class 10th. So that's all right, Ashvi. It's very good that you are answering. You are attending this session, but a lot of these concepts are from class 11. So when you go to class 11, you'll certainly understand. Okay, meanwhile, Shashwat has come up with his answer. Shashwat has come back very, very strongly. Let's see if he gets this one right. Alright, so Shashank has also come up with his answer. And let's see if Aditi does the same. Okay, a lot of answers coming in from the audience. And a lot of people are inclined towards one particular option. Let's see if that is correct or not. So again, there's a question on maximum extension in the spring. Think, when is the maximum extension of the spring going to happen? And think about the displacement of the block, the relationship between the displacement of the block and the extension of the spring. Okay, that's what you need to think about. So if Shashwat and Shashank both, so they have given different answers, so they can't both be right. But if Shashwat gets this right this time, he is going to go on the leaderboard, and if Shashank gets this right, then he is going to maintain his lead, which is just by 1 point. Aditi, what do you think is the answer? The time is running out. Alright, so Aditi has also come up with her answer. I hope you're not done, you're not taken a guess. Okay, so Shashwat has said option C, Shashank has said option B, and Aditi also has said option B. So let's look at the correct option. Can we have the answer, please? And it's option B. Very well played, Shashank. Shashwat was very, very close to you, but Shashank has taken the lead this time, and he has increased his lead. Aditi, very well played. You have come back very strongly, and you are now very, very close to Shashwat. Okay, so the correct option is option B, 4 mg by k. Most people in the audience were thinking it is option C, which Shashwat is also thinking. So let's quickly look at the solution. Can we have the solution on the screen, please? So guys, you have to think about the relationship between the displacement of the block and the extension of the spring. Okay, so at maximum extension, the kinetic energy is going to be 0 because the speed of both the blocks is going to be 0. That's what meant by maximum extension. Okay, but the thing to note here is that the gravitational potential energy is going to decrease only for B. The gravitational potential energy is not going to decrease for A because the horizontal level is the same. Okay, so the loss in gravitational potential energy is the mass of B into G into the displacement of the block. And the displacement of the block and the elongation of the spring is going to be the same, and that is very simple to see by constraint because they are connected in by one rope. Okay, one rope goes to A, and from there one rope goes to the spring. So if B is elongated by X, then K is also going to be elongated by X. So we can put that into the equation 2 mg xm is equal to half k xm square, and from there we are going to get xm is equal to 4 mg by k. Correct option is going to be option B. Okay. Alright guys, so this is the last question for the day. Shashank is in a very comfortable lead. So let's see if Shashank increases his lead or Shashwat and Aditi are going to catch up with him. Okay, so last question for this session today on your computer screen right now. A particle is released from rest at origin. The potential energy of the system is given by U is equal to x square minus 3x. Kinetic energy at x equal to 2 is. And the options are A 2 joule, B 1 joule, C 1.5 joule, or D 0 joule. Okay, so the potential energy of the system is given by x square minus 3x, where x is the x coordinate of the particle. And the particle is released at the origin. Okay, note the words released at the origin. We have to find out what will be the kinetic energy of the particle at x equal to 2, given that no other particle is moving. Okay, that's an assumption in the question that no other particle is there in the system which is going to move. So the kinetic energy is only going to be because of that particle. Alright, audience, what do you think? Alright, so Shashwat has come up with his answer very, very quickly, and so has Shashank. And we are waiting for Aditi. Alright, so answer coming from audience as well, but again we see a lot of different kinds of answers coming from the audience. Let's see if the audience is correct this time. So Lakshya is saying, basically he's giving a hint as to what is the method by which you can solve this question. We'll look at that, Lakshya, for sure. Some people are saying option A, some people are saying option C, some people are saying option D. We also have an option B as answer. We'll check what is going to be the right option. So time is running out, Aditi. The key here is particle is released from rest at origin. That is a very important statement in this question. And the potential energy is given by a function of x. You have to find out the kinetic energy at x equal to 2. Alright, so audience, what do you think? Can you suggest a solution to this question? Can you tell me what method should we employ to solve this question? Doesn't look like a very straightforward question to me, but what is the concept that is involved? What is the key concept involved in this question? Can the audience help me with that? Alright, so Aditi has also given her answer, and yet again all the three participants have given the same answer as option A. So let's quickly check what is the correct option for this one. And it is indeed option A. So we have ended this quiz on a very high note. All of you guys have played a you guys have played really well. Okay, so what are the final scores? Can we have the leaderboard, please? So Shashank is at 26 points, Shashwat is at 19 points. At one point Shashwat was very, very close to Shashank, but when Shashank came back very strongly and he was in a very comfortable lead, and Aditi is at 15 points. Okay, so we know who the winner is. Shashank is the winner for today's RFM. So a big round of applause for Shashank. Very, very well played. You started off very well. In the middle you did lose some steam, but you were able to maintain your lead, which is excellent. And congratulations to Shashank. But Shashwat and Aditi, you guys also played very well. Shashwat at one point had come very, very close to Shashank, and the game could have gone in any direction. Okay, but all of you three guys, you have played extremely well. Thanks a lot for your participation here. And the audience, thanks a lot for your participation as well. As always, you guys are really helping us make this session better and better. Okay, so this was a fun session of Rapid Fire Mondays on work, power and energy. Next week, we're going to come up with another session and another topic. Till then, keep practicing, keep getting better, and have fun with learning. Thanks a lot for watching.